afternoon, ladies and gentlemen. Welcome to the International Webinar on Speech Emotion Recognition using ML, organized by IT Research in association with IRAJ webinars. On the behalf of entire organizing committee, I'm Isaac Behra, organizing secretary, would like to welcome you all for this webinar. Ladies and gentlemen, let me introduce our organization. The motto behind this non-profit association is to bridge the gap between students, professors, academics, and industrialists from multidiscipline. Apart from organizing various seminars, expert talks, and conferences, we have various highly rated multidisciplinary journals in the field of science, engineering, technology, and management. Since our inception, we have been arranged various international conferences at various parts of the world like New York, London, Australia, Hong Kong, Dubai, Bangkok, Kuala Lumpur, India, etc. More than 1 lakh people across the globe are associates with us, and more than 5 lakh research papers have been presented and published during our journey. Today, I'm glad to welcome you all as a member of this fastest growing network for the advancement of science and technology in terms of research and innovation. Today, we were very much fortunate to have an eminent professor and expert who is joining this webinar as an expert speaker and guest. His name is Professor Dr. Gaurav Agarwal. Presently, he's working as an assistant professor in KIET Group of Institution, Ghaziabad. Now I would like to welcome our Professor Dr. Gaurav Agarwal to deliver the webinar.
Very good afternoon to one and all present here. Myself, Dr. Gaurav Agarwal. Today, I got a very good opportunity to put my views in front of you all on the topic speech emotion recognition using machine learning. So when we are talking about machine learning, I can say I will go through with the introduction to the machine learning, basics of machine learning, the general steps of the machine learning, type of data, emotion versus sentiments, processing steps in emotion recognition, feature extraction and selection methodology, sunflower and deer hunting optimization. Finally, we will conclude with the results and discussion, and finally the references. So when I'm talking about machine learning, in this new era of technology, companies and developers around the world are talking about an empirical artificial intelligence, machine learning, and deep learning. All these acronyms are oftenly loosely used in the field of technology. It is important to understand that all these acronyms are part of the AI umbrella. When I'm saying AI umbrella, it is an umbrella discipline that covers everything related to making machines smarter. Machine learning is commonly used along with AI, but it is a subset of AI where ML refers to an AI system that can self-learn based on the algorithm system that get smarter and smarter over time without human interventions. It's known as machine learning, while deep learning is a machine learning subset which can be applied on a larger data sets. So when I'm talking about machine learning, I simply say machine learning is a subset of AI that uses learning algorithms to build smart systems. The machine learning systems can automatically learn and improve without explicitly being programmed. The recommendation system on music and video streaming are the examples of machine learning. I can say machine learning is bifurcated into 3 domains, that is supervised learning, unsupervised learning, and reinforcement learning. Here, supervised and unsupervised is again bifurcated into classification regression and clustering and association analysis respectively. Let's start with the supervised learning. Supervised learning is a process that will have the labeled data, and with the help of this labeled data, we have to train our system or our model. Once the system will be modeled, then we have to test the accuracy of the trained model with the help of the test data. While we do the testing, we have to predict the output. Once the predicted output is equal to the expected output or the desired output, I can say our machine is performing in a better manner, in a good manner. While when we talk about unsupervised learning is a learning where we cannot be directly applied to the regression or the classification problem. because, as the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training data set. Instead, model itself find the hidden patterns and insight from the given data. It can be compared to learning which take place in the human brain while learning new things. It can be defined as, let us define with the help of an example. Suppose the unsupervised machine learning algorithm is given an input data set containing the images of different types of cats and dogs. So when we have these images, we can assume the algorithm is never trained upon the given data set, which means it does not have any idea about the features of the data set. The task of the unsupervised learning algorithm is to identify the image features on their own. Unsupervised learning algorithm will perform this task by clustering the image dataset into the groups according to similarities between images. Now, the next category is the reinforcement learning. When I'm saying reinforcement learning, it is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of action. For each good action, the agent gets the positive feedback, and for the each bad action, it gets the negative feedback, or we can say the penalty. When we talk about the general steps that involve in the machine learning, we can say we will have the input data, and from the input data, we have to prepare the model. From model, we have to train the model that we called it as learning. Then after training a model, we have to do the performance evaluation. Generally, the performance evaluation is done with the help of confusion metrics. And finally, there we have to tune the model with the help of that we called it as performance improvement. So if we talk about the types of data, there are basically two types of data. One we called it as qualitative, and second we called it as quantitative. When I'm saying qualitative means it contains the data. It contains the data that is having the texture values, that is a nominal data or the ordinal data. When I'm saying quantitative data, it means it contains the numerical value, that is discrete data or continuous data. Continuous data can be of two types. It may be an interval or a ratio. So let us have an example of it. So when I'm saying my example, we are having a file that is human readable file. So in this human readable file, what we are having the pets, and these pets are cat, dog, turtle, fish, and cat. But we cannot save this file exactly into a machine readable format. To save the file into a machine readable format, what we did is we put all the different categories, cat, dog, turtle, fish, as the columns, and where the particular cat is belongs, we put it as 1, and the rest of the column values will be termed as 0. When I'm saying dog, the dog will be in the second column, then I put it as 1, and the rest will be put it as 0. If I'm having an example of feature construction, let us consider this data. In this data, what we are having the qualitative values as well as the quantitative values. So machine learning, basically we applied on the quantitative values. So to convert this table, what we are having, we can convert it like this. We are having age, then origin city. Cities of three types: city A, city B, and city C. City A, city B, and city C. Then what I did is origin city A, origin city B, and origin city C. Then we are having the parents as an athlete, and for this particular column, we are having two possible values. Either we are having yes or we are having no. So we are having parents athlete and Y, and parents athlete no. And finally, we are having the chance of win. When I'm saying the chance of win, it may be no or it may be yes. So to convert this qualitative data into quantitative data, we put it 1 and 0. But there is a problem. The problem is when I'm talking about parents athlete Y or N, it simply means if it is Y, then value is 1, and if it is no, then value is 0. So there is no need of this particular column, parent athlete N. Similarly, when we are talking about chance of win, it is Y. So obviously the second value is no. So to remove this value, what we are doing is we are putting the values as 1 and 0. So after removing these two columns, we are having the dimension of the dimension of our data is 6 by 6. So there will be total 36 data elements into this data. Now, before starting to the emotions of machine learning, we have to understand the concept of emotions versus sentiments. When I'm talking about emotions to sentiments, I can say emotions are of different categories. It may be like anger, it may be sad, tired, exhausted, calm, relaxed, happy, and many more. But when I'm talking about sentiments, sentiments can be of only of 3 types. It is like positive, negative, or neutral. So there is a very clear difference on the basis of balance and arousal. So if balance is from negative to positive, it means a person is moving from angry mood or the angry emotion to a happy or a relaxed emotion. While if I'm talking about arousal, if the value of arousal are moving from negative to positive, it means from the exhausted, the person is moving to the excited mode. Now the articulars for the vocal, when I'm saying the articulars for the vocal, it simply means vocal emotion acquires a meaningful role in the daily conversation between several pupils. In order to achieve an intelligent decision, emotion acts as the major requirement. Human emotions are the most complex task, which includes feeling, behavior, and thought of the pupils. So if I'm talking about the emotion, then emotions can be termed as, or it can be considered as the glottis, and glottis is nothing. It can be seen by touching our throats, that we called it as, it can be seen by touching our throat, that is the hardest portion of the throat. We called it as, in Hindi, we called it as kan. So the vocal folds, we are having 2 vocal folds. In order to produce the sound or a vocal from the vocal folds are supposed to become together, and when the air passes through them, it should vibrate. So when vibration is there, it should pass from the glottis and reach to the velum. And when we talk about velum, there are 2 possibilities of velum. Velum may be fully open or it may be closed. If the velum is open, whatsoever the vocal we are creating, it comes from the oral cavity. If the velum is closed, then the vocal will be come out from the nasal cavity. Based on the complete literature, the vocal is bifurcated into 3 domains, that is voice, music, and speech. So here my presentation is to find out the emotions in the speech. So I'm concentrating the further presentation on the speech only. When I'm talking about processing steps in emotion recognition, then the basic steps are, we are having the speech, music, or the voice as an input. We have to pre-process the input, doing the feature extraction and followed by the feature selection. It will be have the processing module, and from the processing module, we will pass the selected features to the classification or the classifier, and finally, we are having the emotion as an output. Whatsoever I'm saying, it is in a form of an acoustic signal. When I'm saying acoustic signal, it means it is a mechanical wave or an acoustic wave. So it is having a time as an amplitude. So we cannot save this wave into the systems. To save the wave into the systems, we have to do the sampling. And what the sampling is? Sampling requires 2 things. One is sampling interval and second one is sampling frequency. Sampling frequency means the number of samples per unit time, and the sampling interval means the time difference between the two adjacent samples, we call it as sampling intervals. Suppose we are recording a voice at a frequency of 44.1 kilohertz. That means in 1 second, we are having 44,100 samples were observed. So if we are having an audio of 1 minute, then the total samples will be 60 into 44,100. That make 2646,000 samples. To store this, we are having either we are using a 16-bit or the 24-bit encoding technique. If I am using a 16-bit encoding technique, then it can store a values of 65,536. If there is a peak difference of -1 to 1 and I divide 1 by 65,536, then it will give a voltage interval of 0.00003 that will be stored, and the minimum the voltage interval, the better the regeneration of a signal. So we are having these black dots are the samples, and we have to form the vocal array from it. So when we are forming a vocal array, these dots are supposed to be saved into a computer memory. So when we save the dots into a computer memory, it is take a form of vocal array represented by A of n, and the values will be stored like 0.5, 0.75, 0.75, and so on and so forth. The complete signal will be stored in this format, and these are the values which we called it as values related to the features or the input signal. So what we are doing is we are having a speech signal. The speech signal may have, when we record any signal, it may have the noise also. We have tried to remove the noise with the help of AWT, that is adaptive wavelet transform, with modified Galtic swarm optimization technique. After removing the noise, or we can say pre-processing the signal, we did the feature extraction. After having the feature extraction, we will have we are find the features that relate to the prosodic and the spectral features. After feature extraction, we selected the features with the help of adaptive sunflower optimization technique, and after selecting the features, we will pass the selected features through the speech emotion recognition model, and after classify the signal, we will have an output in the form of emotion. It may be angry, fear, disgust, happy, neutral, calm, surprise, or sad. Suppose we are having a signal, so it is supposed to be decomposed. When we are talking about a noise can only be available in the higher frequency. So to decompose the signal, we have applied the discrete wavelet transformation. And when we are applying the discrete wavelet transformation, we are having two types of coefficients. One is we called it as detailed coefficient, and second we called it as approximation coefficient. The approximation coefficients are the one which are having the higher frequency, while the detailed coefficients having the lower frequency. When we reconstruct the signal, we have to select these red lines. For selecting of these lines, we have applied one technique that we called it as super soft thresholding. Basically, there are two types of thresholding. One we called it as hard threshold, and second we called it as soft threshold. But because it is a research work, what we did is we make a combination of the two, and we give it the name as super soft threshold. What exactly it is? In soft thresholding, if the value of the signal is less than or equal to the tau value, then it is 0. But why we called it as super soft? We put the original signal as it is if it is less than tau. Then to convert it into the signal, we apply inverse wavelet transformation, and we calculate the mean square error, means from the original signal and the reconstructed signal. If this error is 0, we can say we have reconstructed the signal as proper as the original one. If there is a difference between the two, that will be represented as mean square error. Now, how we can select this MDSO or the value of the threshold? For the selection of this threshold value, we have used galactic swarm optimization technique. It is a part of nature-based optimization technique that we called it as particle swarm optimization. From that, we have randomly generated a values that is related to E from E1 to En. Each value may have the velocity associated with it. So the value velocity associated with it is represented by V1 to Vn. So if we take the first value as Ej, then Jb any value that lie between from E1 to Em. After having this Ej value, we calculate all the previous steps, and for applying any nature-based optimization technique, we have to give one objective function. So the one objective function for this is we have to minimize the value of this error. If this error is minimum, we can say the objective has been reached or objective has been successfully achieved. Else we have to do some other task. So I can say if the mean square error is maximum, I can say the objective is not reached. If following this line, we can reach the mean square value as 0 or almost equal to 0, that will the value of tau for me. That is the value of the threshold. When I'm talking about feature extraction done in emotion, we can have a different type of features. It is like spectral features, prosodic features, music, and qualitative features. Here in spectral features, it means the features that are related to the frequency. When I'm saying prosodic, it means it is a time domain based features. Because we are not here, we are dealing with the music. So let's skip these two type of features and let's start with the spectral features. If I'm talking about a human being, then, or I can say every creature available on the earth must have a hearing range. So if I'm talking about an elephant, the hearing frequency of an elephant is from 14 hertz to 12,000 hertz. But when I'm talking about human being, here the hearing frequency is from 20 hertz to 20,000 hertz. So in the same way, whatsoever the creature is available on earth is having the hearing frequency as lowest and maximum. On the basis of this, let us try to find out the MFCC features that we called it as mal frequency cepstral coefficient. For that, let us consider an example. Here, I'm having an recorded audio signal. Really sorry. The duration of this audio signal is 3.525 seconds. So if I would like to save this signal, I need to have this signal in the form of time and frequency. But if I directly apply the fast Fourier transform, what it will give the complete signal in a form of frequency to magnitude. To avoid all this, what we did is we apply short time Fourier transform. The short time Fourier transform, the complete signal is represented as xt, and here xt, the domain of xt is 28,200. From where I am getting this value, the duration of the signal is 3.525 seconds and the frequency of the signal is 8,000 hertz. So when we multiply the frequency with seconds, it gives us a domain size of 28,200. Now, in order to avoid to take a complete signal in a single go, we have to bifurcate the signal into a small chunks. For the bifurcation of the small chunks, we have applied the Hamming code function, and this is the standard formula of using the Hamming code. What has happened after applying this Hamming code? The complete signal is represented in the form of this type. So you can see there is a triangular type shape, and two consecutive triangulars are overlapping each other. So on a particular triangle, we have applied the fast Fourier transform and convert that signal into the time to frequency domain. How I did it? Let us see. The one triangle represents a signal duration of 25 milliseconds. When I'm saying 25 milliseconds, it is equal to 0.025. So the domain size is 200. How we get it? Signal size is 0.025 multiplied by the frequency, that is 8,000. 8,000 multiplied by 0.025 will give me a domain size of 200. But if I'm applying the complete signal, then the two consecutive triangles are overlapping each other. These overlapping, we called it as frame step or step size. Here, the overlapping is of 10 milliseconds. Again, the 10 milliseconds multiplied by 8,000. So the domain size is 80. If I represent the complete signal into this small windows, I can say 28,200 the domain size, each represent 200 divided by the frame step. The total number of chunks which we created in a signal of 3.525 seconds will be 350. So the complete signal can be represented in a domain of 200 by 350. That means 200 for a single domain followed by 350. For this, we take a single window and applied the discrete Fourier transform. When we applied the discrete Fourier transform, what it will do? It will take us from real numbers to the imaginary numbers. And it is very sure no one in this world would like to deal with the imaginary numbers. So we have to apply the discrete Fourier transform coefficients. And when we applied the discrete Fourier transform coefficients at k equal to 257, we will have the periodogram estimation of the ith frame in the form of power spectrum. This power spectrum is represented as P and the domain is 257 into 350. Now a single signal of 200 is having 250 domains to 257 Fourier transform coefficient. So the total signal is 257 into 350. Till now, what we did is we are dealing with the frequency, but human being is not able to hear the frequency. They are in hertz. What we are hearing in hertz. To convert that into the hertz, we have applied the Mel space filter bank. In this, we are having the lower frequency as 300 and the uppermost frequency as 4000. But the problem with this is we are dealing with the logs. As we are not interested in dealing with the logs, we are converting this frequency to a Mel scale. And when we are dealing with the Mel scale, we are having this type of formula. If I will take the inverse of it, simply it will convert the Mel scale to hertz. So in MATLAB, I've implemented the complete concept in the MATLAB. In MATLAB, there is a formula that we called it as linear space. And when we implement the linear space, we pass the minimum frequency, the maximum frequency, and the number of triangular filters. When we did it, it will represent the complete filter in this form, the complete signal in this form. If I will calculate the triangles from 300 to 4000, it will be 26 in numbers. So it can be represented as 26 into 257, and it is in a form of energy. Energy is nothing, that is T multiplied by P which we have calculated in the previous slide. In that previous slide, that let us check. In this, the dimension is 257 by 350. So 257 by 350, 257 will be cancelled out. So the final energy domain will be 26 by 350. Now, the amount of energy in a filter bank L at frame I can be represented as in this form. Here, now, the question is, we are having two possibilities, whether we have to deal with the machine learning or we have to deal with the deep learning. If I am dealing with the machine learning, then I can say this is the input, this is the first input to our machine learning model. This is our first input to the machine learning model. If I am dealing with the deep learning model, And if I'm dealing with the machine learning, then I have to take the discrete cosine transform of it, and we will have the signal in the form of time to MFCC coefficients. So the upper model for the deep learning and the second model for the machine learning. Whatsoever I have explained, the complete concept has been represented with the help of this diagram. Similarly, we can find out the number of signals, the number of features, that is LPC, linear prediction coefficient, PSD, power spectral density, and many more features. Now, whatsoever the features we have extracted, it's always not necessary that all the extracted features may be equally important to us. So to select the important features, we have applied the SOM optimization method that we called it as sunflower optimization. Let us say if I'm expecting the m number of features, then each feature is represented as f1k, f2k till fmk. Because we are having the number of chunks of a signal, so here fik represents the ith feature of the kth audio signal. Now we will check it. We are having a weighted matrix represented by W1 to Wm. M is the number of features. Here I've applied the binary weights. The binary weight means the weight should either be 0 or either be 1. If the weight is 0, it simply means that feature is not contributing. That feature is not contributing into the emotion recognition. If it is 1, it means the feature is 100% contributing to that emotion recognition. For checking it whether a feature is contributing or not, we have applied the KNN model, K nearest neighbor model. What I did is, let CK be the target class of the kth audio signal, and CK can have any value from this domain, that is angry, fear, disgust, happy, neutral, calm, surprise, or sad. If the TK be the target class, then if it belongs to the disgust, I can say it belongs to number 2. That means angry is 0, fear is 1, disgust is 2, happy 3, and so on and so forth. In the same fashion, what we did, feature is multiplied by W1, that is the weighted matrix. If there are m number of features, I can say there can be 2 to the power m number of possibilities of this weighted matrix. I have tried m number of possibilities, and when I tried it, I will make it f1k, w1, f2k, w2, and so on and so forth. And we have worked on a fitness function. The fitness function is minimum of this. If the means the predicted output is always be equal to the target output, I can say the error is 0. If the predicted output is not equal to the target output, I can say the error is 1. Because we are dealing with the binary weights, so value may be either 0 or 1. For the complete weighted matrix, for which we are having the minimum error, that particular weight matrix will be selected, and on that basis we can move and we can select the features. So there is a problem with the classifiers. The problem with the classifiers is, if we are having a different layers, then if we have to change the weights cannot be propagated to the first layer. To change the weights to the first layer, we have applied the deer hunting optimization. When I'm talking about deer hunting optimization, we are having a hunter, we are having a deer. So whenever the hunter wants to hunt this deer, there are number of possibilities shown by the different dots. And for this particular hunter, there are again 3 possibilities, that it may go to the leader's position, it may go through the through position angle, or it may go to the position of the successor. But the target is to hunt the deer. If these are the coordinates associated with the hunter, then the best coordinates will be Y star, Z star. Whether the leader will reach to these coordinates through the proposition angle, or the successor will reach to this coordinate through the proposition angle. The one who will reach to this coordinate, then and then only this deer can be hunted, else it will not be hunted. On the basis of this, we have applied the complete technique, and the complete concept which I have explained till now is represented with the help of this diagram. That is, we are having the speech signal data set. We have done the denoising using AWT MGSO. Then we did the feature extraction. Then we have the feature selection, followed by the speech emotion recognition. And finally, we are having the emotion output. This is the proposed algorithm which I have used. Now, finally, the results and the discussions. When we are having an input in the form of a noise signal, input signal as a speech, then it may and may not have the noise. After having the input signal, we have removed the noise. So, when we applied the AWT MGSO, what will happen? Let us check. If you will see the original signal, in the original signal, when I applied deep neural network, then it is 85.36% accuracy. When I have applied deep autoencoders, the accuracy is 84.89%. But when we applied the deer hunting deep neural network with the deer hunting optimization, then the accuracy improves to 92.43 for the original signal. But when we applied the AWT, the accuracy further improves. The best accuracy has been achieved when applied adaptive wavelet transform with the optimization technique with the proposed algorithm. Then the accuracy reached to the 97.15%. Normally, any data sets can be the performance of any classifier can be measured with the help of the confusion matrix. When I'm saying confusion matrix may have the different values. It may be true positive, true negative, false positive, as well as false negative. On the basis of this, this complete matrix has been designed. If I will say this diagonal elements are representing the true positive values, means it shows the accuracy of the proposed model in terms of percentage. Let us see. These are the emotion classes for which the complete model has been tested and trained. We have correctly identified 34 and incorrectly identified 0 when I'm talking about our emotion category discussed. The technique which we have applied, DNN DHO, so the accuracy is 100% of the model, and when I applied the deep neural network, then the accuracy is 97.1, and deep auto encoders give an accuracy of 94.1. Similarly, for angry, we are having 35 correctly predicted models and signals, and one incorrectly predicted signal. So the accuracy is 97.22. So it can be measured here. We are talking about RevDes dataset, angry 97.22, RevDes, and where is angry? Let us check. This is angry, it is 97.22 accuracy. In the same fashion, if I will talk about the Hindi dataset of the speech that I have taken from IIT Kharagpur, then we are predicting the accuracy of 99.50 as a maximum, and minimum accuracy which we get is 87.5 when I'm talking about Hindi datasets. When I'm talking about Toronto emotional dataset, it is a foreign language dataset, and in this, the maximum accuracy which I received is 98.57, and the average accuracy on this particular dataset of the proposed model raised up to 97.86% when it is compared with deep neural network 96.10 and deep autoencoders 94.70. The complete discussion on the previous two slides has been represented here in the form of accuracy, precision, F1 score, sensitivity, specificity, and FPR. FPR, we called it as false positive rate. When I'm talking about precision, the precision is simply a measure of representing as fractional of significantly identified instances. It is compounded through the subsequent conditions, that is true positive, when it will be divided by true positive with false positive. Whatsoever the value we will get, we will call it as precision. If I'm talking about this F1 score, then F1 score can be calculated as twice of true positive or divided by twice of true positive plus false positive, false negative. I can say F1 score measures the estimation of harmonic mean of the recall and the precision. In the same fashion, we can calculate the value of each and every performance measure, whether it may be accuracy, F1 score, sensitivity, or FPR, false positive rate. When the proposed model has been compared with the existing models, then what we found is on error rate, the proposed model has the minimum error rate on all the three data sets, whether it is Toronto, it is RevDes, or it is IIT Kharagpur data sets. So, but the deep autoencoders shows the worst result when applied on the three data sets. Again, I am from this diagram, I have tried to represent you the training and the testing accuracy of the models. When I am saying training and the testing accuracy, it is shown as the training of DN and DHO model is at its best when I'm using with the deer hunting optimization. When the model has been trained with this DNN, then I can say the accuracy is a little bit lower in comparison to DNN, DHO, and finally, deep autoencoders have the minimum training accuracy. When I'm talking about the testing accuracy, then the testing accuracy is maximum on DN and DHO, which we can clearly visible on the basis of the results also. Finally, when we compared our results with the existing results, then we find out the basic problem with the existing results are they are dominating on a single type of features, whether they have selected the high level features or the low level features. But in the proposed work, what we did is we used the two type of features that are spectral and the prosthetic features. That's why the accuracy of the proposed model comes out to be 97.14 for RevDes, 93.75 for IIT Kharagpur, and 97.85 for the test datasets. For the complete presentation, I have read out a number of research papers that related to the SCI or the scopus in this general belongs to the Q1 or Q2 category. Almost, I have read almost 62 papers, and that's all from my side. If anyone is having any queries, then feel free to ask. Over to you, sir. If there is no query, then please.
Thank you, Professor, for sharing your valuable time and for joining this webinar. On the behalf of the organizing committee IRAJ webinars, I would like to thank all our sponsors and coordinators. I'd also like to thank our president. We're happy to hear your comments and compliments or suggestion at our Facebook and Twitter page. This video will be available shortly in our YouTube channel. Kindly subscribe our official YouTube channel, IRAJ Conferences and Seminars, for all past and upcoming webinars and expert lectures. Thank you all. See you another webinar soon. Thank you, Professor.
Thank you, sir, for providing me a wonderful opportunity, and really thankful to you.
Thank you, sir.
Thank you, sir.